Okay, in section 12.5 we're going to continue our work with the normal distribution. We talked last time about having trying to solve problems that involved data points that actually landed on one of the 6 data points in terms of the z-scores, either 1, 2, 3, or -1, -2, -3. And we found percentages by using the 68, 95, 99.7 rule. Okay, however, I mentioned last time that if it did not land on one of those nice numbers, how do we handle that situation? Well, we're going to look at that today. So before we start, I'm going to point out to you in your book that on page 720, this is also in your notes, you have a z-score table, okay, that gives you percentiles. Okay? And what we're going to be doing with this table is we're going to be calculating some of those percents. Now you'll notice that this accounts for all the z-scores from -4 up to 4, going by 0.5s, okay, and then going by 0.05s between -1 and 1. Okay? So it gives us quite a bit of data. Of course, it doesn't cover every particular case. If we had a z-score of 0.46, obviously 0.45 would be the closest one to that. We would just use that then, because there is no 0.46 in the table. Okay? So let's start out by looking at a situation where we want to find the percentage of data that's less than a given data item. So similar to problems that we had in the last section, it says according to the Health and Education Department, cholesterol levels are normally distributed. With men 18 to 24, the mean is 178.1, the standard deviation is 40.7, and we want to know what percentage of men in this range have a cholesterol level that's less than 239.15. Okay? So anytime we're looking for this less than percentage, okay, what we want to do is calculate the z-score. So data item minus mean divided by standard deviation, in this case is 1.5. So that is our z-score, and what we're going to do is we're going to take that table I just pointed out, and we must find the percentage of men with a cholesterol level that are less than 1.5. Okay? The table gives this percentage as a percentile. So finding 1.5 in the table, if you look at your table that I just showed you a minute ago, this is just a portion of it, of course, we would see the answer is 93.32, and therefore that is the answer in this case. This is the easiest case scenario, and the answer is just simply 93.32% of men that are between those two ages have the cholesterol level that's less than 239.15. Now, if we were asked the opposite question, like as in on page 722, if you look with me, we have an example here that says the lengths of pregnancies of women are naturally distributed, means 266, and the standard deviation is 16. And this time we want to know what percentage of children are born with pregnancies that last more than 274 days. So same process, we're going to calculate the z-score for that. The z-score happens to be 0.5. Okay? And ultimately what we want to do this time though is that we want to take that z-score, find it in the table. We see 69.15%. And what we're going to do then is subtract that from 100, and that'll give us how many more. Okay? Think of why that seems to be reasonable in this picture. If we find this is 274, this is a half a standard deviation above the mean. Okay? The table gives us everything that's below that. That's what the table gives no matter what z-score we have. It's going to give what percent is below that line. So if 69% is below that line, that means 31% better be above that line, because again, the whole entire diagram itself is 100%. Okay? So a little bit more work to do when we're asked for greater than, because we have to take the percentage we find in the table, okay, which again is 69.15, and we have to subtract it from 100 to get the green part, if you will, in this table. Now, third case that we're going to work with is dealing with what if we have to find a between situation. Okay? So if we want to know the percentage of data between two given items, what we're going to do is the following. We're going to convert to each data item, we're going to convert to a z-score, so we're going to be finding 2 z-scores. We're going to use the table to find the percentile that's corresponding to each z-score. And then what we're going to do is we're going to subtract the lesser percentile from the greatest and attach a percent sign. So that's kind of an overview of what we're going to do. Let's go ahead and see that in action then. And if we look at the next one I have here, it says the amount of time that self-employed Americans work each week is normally distributed. 44.6 is the mean, 14.4 is the standard deviation, and we want to know what's the percentage that are between 37.4 and 80.6. So we'll go ahead and calculate the z-score for the smaller one. 37.4 turns out to be -0.5. The 80.6 turns out to be 2.5, and so from there we're going to look at our table. We're going to find the percents that belong to those z-scores. And in this particular case, the percent that belongs to negative 0.5 is 30.85. Okay. The percent that belongs to 2.5 is 99.38, again coming straight from that table. And ultimately, that means that the two numbers that we got, of course, as I mentioned, are the 99.38. This is for the z-score of 2.5. This one corresponds to the z-score of negative 0.5. Okay, and ultimately, if we subtract those two, that's going to give us the amount in between. And again, looking at the picture, think about why that makes sense. If your 80.6 is way over here, 2.5 above the mean, 0.5 below the mean, okay, and we know that that 99.38 is to the left of that line. Okay, we know that 30.85 is to the left of that line. Then in between those two would make sense to subtract, and therefore we get the 68.53%. So three different types of problems that we're going to deal with when we're going to use our table to come up with these z-scores, okay, and the percentiles that belong to them. In a summary, you have on your page 724, same summary I have here. We are looking for a percentage of data that's less than a given item of the particular z-score. We're going to find the table. We're going to find that table and find the percentile that belongs to that z-score, and that is the answer. Okay. If we have a greater than situation, then we're going to find that same percentage from the table, given the z-score that we find, and we're going to subtract it from 100. And if we have two data items, we're going to find both z-scores, find the percentiles from the table, and then subtract, and we'll get our final result.